morning and welcome back to the Science Fair. We're Team 14 from third semester Group E, and we will be talking about conic sections and more exactly about the parabolic solar heater.
We are going to explain the functions and the application of the parabolic solar heater. Also, at the end of the explanation, we're going to have an activity, so don't miss it.
Hey, wait! But first of all, for us to understand what is a parabolic solar heater, we need to know what's a parabola. Basically, a parabola is a conic section that is formed by the intersection of right circular cone and a plane parallel to an element of the cone.
Okay, so the parabola has many properties, and one of the most important properties of the parabola is the reflective property. That says that any ray parallel to the axis of symmetry gets reflected off the surface of the parabola and goes to the focus.
Okay, so the parabola has some main elements, and some of them are the focus, which is a fixed point inside of the parabola. Then we have the directrix, which is a fixed straight line, which is perpendicular to the axis. Then we have the axis, which is a line passing through the focus and the vertex. Then we have the vertex, which is where the parabola takes its shape. Then we have the lactus rectum, which is a line that goes through the focus, and it's also a straight parallel line.
Let's talk about the history of parabolic solar heater. The first record about the use of solar energy for cooking are from 1767. Then, around the 1860s, Augustin Mochet combined the box heat trap with mirrors in order to create a solar oven. Now, let's jump in time, and in the 60s the United Nations started working in more complex solar heater systems. And nowadays, solar heaters and parabolic solar heaters are more common, and we should start using it if we want to help our environment.
A parabolic solar heater is a solar thermal energy collector. It's designed to maintain all the sun radiation into a large surface area and the focus. Or, in other words, it contains all that radiation into a small focal point area, increasing the solar energy by more than a factor of 2, which means more overall heat per square meters of true.
The shape of the concentrating solar collector must be specifically designed so that all the incoming sunlight reflects off the surface of the collector and arrives at the same focal point no matter what part hit first. This shape is the parabola.
And now you might be wondering how the parabolic solar heater works. Well, I have the answer. I'm going to explain how they work. These solar heaters use a system where the sun's energy is captured by using large mirrors that are connected to track the sun's movement throughout the day. When the sun's heat is reflected off the mirror, the curved shapes send the most of that reflected heat onto a receiver pipe that is filled with a specialized heat transfer fluid. The thermal energy from that heated fluid generates steam and electricity. When the heat is transferred, it is reused again.
The radiant energy will be the energy responsible of heating the focus of our parabola. This type of energy, also called electromagnetic energy, is transmitted through an elementary particle called a photon. It interacts with matter to transfer a fixed amount of energy. This energy has a speed of 3000 km per hour, and it travels in space forming waves of various lengths and frequencies. This type of energy is present in the solar heat that will be the heat responsible of heating our parabola. Something important to take into account is that the radiant energy is able to heat an object only if atoms, molecules, of this object can absorb electromagnetic waves of a specific wavelength, and that the radiant energy is different to the thermal energy. Thermal energy generates heat by the movement of particles, while the radiant energy, as said before, generates the heat if a surface absorbs the electromagnetic waves.
For this experiment, we are going to need 6 materials. The materials required are silicone or glue, cardboard, a cutter or scissors, a box of shoes, aluminum foil, and black paint brushes.
Parabolic solar heater that is awesome because we apply all the concepts that we have seen across the video. So we're gonna teach you. It is easy, simple, done the best engineer in the world, but we are going to prove how this can and may cook the food. So you can make like a barbecue, nah, not like that, but it is very cool how if we apply the concepts that we show you, it creates this simple but very efficient solar heater.
The procedure is very easy. The first thing you have to do is to paint all the box of black and take the measure of its width and its height. Our box measured 14 centimeters of height and it had a width of 22 centimeters. While the painting is drying, calculate the focus. For this, we're going to use the next formula.
Focus is equal to the half of the width squared divided by 4 times the height. In this case, it would be 11 squared divided by 4 times 14. That is 121 divided by 56, which gives us 2.16 centimeters. And there is it. You have the focus.
Then, in a cardboard, put the aluminum foil and make a parabola with it in the box. Paste it with glue and do a hole in the height of the focus in both faces of the box.
Thank you so much for your attention, and don't forget to do your activity, and we will see you here next time.